Okay, good morning, everybody. I'm Danny Lav. I'm a PLM in Nokia Cloud Band. With me on the stage, Ifat Afek, Vitrage PTL, and Ricolin Heat PTL. So, in our session today, we will demonstrate an integration of three OpenStack components to achieve a self-healing solution. So a cloud operator provides continuous service to its customers. So every service has its own parameters and the service level agreement on how the service is disrupted and restored to achieve this SLA. So the automated procedures in the OpenStack and the cloud operator must achieve an automated methods in order to sustain the service level agreement, mainly for real-time and high availability services that will comply with the SLA of this service. So the solution that is required by the cloud operator is to have an automated method that is not including human intervention in order to restore the service in order to comply with the SLA. Ricolin will explain and the challenges with the self-healing solution and how we solved it together with Vitrage, Mistral and Heat, and we'll see later a demo by Ifat of the solution and more details how to do the implementation. Okay, cool.
Okay. So we started here by some motivations by like the user required and some of the actual like the cases we've been facing. And let's start by talking about the challenges we have. So we're trying to do is self-healing. But self-healing is hard in certain level. Like you want to do it like automatically because you are self-healing something which it heals shouldn't be like ask you to like access to the VMs or whatever that is and trying to figure out where it's wrong and trying to figure out what you should do and actually do stuff that is not smart enough. And that is not something you wanted when you asking for a self-healing. So self-healing means it automatically generate a flow to heal the stuff, to see the stuff, to know what's wrong and heal the stuff. And then there's a stability issue. So you're trying to heal something, but you don't want to break the service. You don't want to like unstable healing. Like, okay, if you only got one VM, it might be easy. Like, I just asking the VM for information, the VM will tell me, and then I just do something. I can even do it manually, like in seconds. But think about you have a large scale. So if you have like hundreds of thousands of VMs, those information sending around and those monitoring those things going around must be crazy. And under those crazy stuff working on, you mean stability is really important. And across that, just mentioned, like thousands of stuff, that means you might have to scale up or down or even crazier scale based on what you have or even across your center. So scalability, on the other hand, is a totally different issue. We've been trying to have a lot of conversation in the communities or across a different user groups to talk about what they needed. And people usually start from having discussion with one VM, but to talk about more resource on top, and like for just saying like 1,000 VMs, but we're not just having 1,000 VMs. We're having something to monitoring, and we have something to find what's wrong. like Vitrage, we have something to do the automatic. We have something to make sure the flow is working. So we have a lot of services nearby your VMs say, I want to be a part of what you're trying to scale up or down. So the scalability is very essential, and you don't even bother to mention the identities, the authenticate and authorizations. Those things you need to consider. So there's also consistency. Say, I want to auto heal stuff. Will be fine. I can do it by typing a script. But what if I want to do another and another? From operator point of view, you want to do stuff consistently, so without trying to do so different every time. That could be like one-time auto self-healing stuff, but it's not long-term stuff. So you want to be consistent, so you might want to put it in the template in something. And finally, I would say it's very essential to actually find the root cause. Because if you don't find the root cause, what are you healing? I mean, a lot of like fancy cluster stuff nowadays usually just ask you to, just kill it and you will restart a new one and you should be fine. And what happens if that is actually not the root cause? What happens if the root cause is actually something else? Like a doctor give you a pill and the pill is not healing you. Actually, it's not working at all. It might be just a candy, and that's not ideal. So finding the root cause definitely help actually trigger the right flow to heal. So let's start by talking about Vitrage, since that's one of the essential things to have a root cause. There you go.
Thank you, Rico. So I'll start with a very brief explanation about what Vitrage is all about. And then I'll describe and show a demo of how to configure Vitrage using Heat. I'm not sure if you are all familiar with Vitrage. It's the root cause analysis service of OpenStack. Suppose you are a cloud administrator and something breaks in the system. Maybe it's a small problem, but maybe like a network failure can affect a lot of resources. Two things can happen. I mean, either you monitor all of those resources and you get like a very large list of alarms, and it's hard to say what to look at first and what's more important. And Vitrage helps you pinpoint the problem and the root cause of all the alarms and what you should handle first. On the other hand, maybe you don't really monitor everything. Vitrage helps you detect all the affected resources and raise additional alarms on the resources, modify their states accordingly. So it gives you a complete view of the real status of the system. And the way that Vitrage does it is by its unique knowledge of the topology of the system. Vitrage maintains a topology graph of all resources that exist in the system, from the physical layer to the virtual layer to the application layer. And using this graph, it's possible to actually understand how different resources affect one another. The graph is taken from different data sources, from all of OpenStack components, and not all, but the main ones: Nova, Cinder, Neutron, Heat. We have a Kubernetes cluster support. And in addition, Vitrage connects to external monitors. Currently, we support Zabbix, Nagios, CollectD, and Prometheus. And all of this is combined into one graph where you can understand the relations between different alarms. OK, so I just explained about Vitrage. And the purpose of Vitrage is to provide you insights about the system. Vitrage does not take corrective actions. It's not built for it. It's also not a monitor. It just gets alarms from other monitors. And if you would like to have corrective actions or self-healing, the best way to do it is using Mistral. I suppose you all know Mistral. It's the workflow service of OpenStack. You can write simple healing workflows, which I will show one in the demo. You can write very complex healing workflows. Maybe you can choose to execute additional health checks if you get a specific alarm. So it gives you the combination of Vitrage together with Mistral gives you a lot of power to combine the insights with actual actions to take place. This integration exists since Rocky, so you could use it a while ago, but you had to configure it yourself to write a Vitrage template, which I will explain about later, that execute a specific Mistral workflow. And now, sorry. Now in Train, this is what I'm about to present is currently work in progress in Train. Hopefully it will enter the Train release. We will be able to configure everything inside Heat template. So you will have in one place the Vitrage configuration, the Mistral workflow, and you will see exactly once you deploy a Heat stack, how its self-healing is going to take place. So together, it will be used to automate the self-healing scenarios, and I will switch to a demo.
Sweet.
OK, so this is the Vitrage entity graph. This is a very small graph, just meant for demo purposes. You can see, but you can get the impression of how we manage the relations. For example, you see the Nova host. You can see some details about it. It's currently, its state is available, everything is OK. And in this example, it is connected to a network bridge with two network interfaces, just to explain about the relations between the layer. And now I'm bringing down a network interface. So I'm actually causing a no connectivity on the host. This is Zabbix. Zabbix is a very common open source monitor, very commonly used. And now Zabbix is about to detect that the network interface is down. Of course, Zabbix is not aware of the effect of this alarm. And immediately, Zabbix notifies Vitrage that the network interface is down. And here you see in the graph several changes. First of all, the network interface is now, its color is now red. Its state is error. And this was done by Vitrage. So all we got from Zabbix was a single alarm that the interface is down. And Vitrage decided to modify the state of the network interface to indicate that it's in error. In addition, Vitrage raised an alarm on the host. There is no network connectivity to the host. And the state of the host was also changed to error. So there will be a clear indication that this host is unreachable now. And one more thing that you do not see in this demo, but in the background, Vitrage also notifies Nova. Nova has a special API to mark that the host is down. Nova is not monitoring the state of the host, and if you go and run Nova service list on the host, you will get the impression that everything is OK, but this is not the real state. So here, Vitrage also calls Nova, say that the host is down. So for example, if someone asks to launch an instance, this host will not be considered as an optional host for a new instance. So this was basically what Vitrage can do. In Vitrage Alarm View, you see the list of all alarms currently active in the system. One was raised by Zabbix. The other one was raised by Vitrage. And you can open the root cause analysis view to see that one alarm is the root cause of another alarm. OK, and now bringing the network interface back up, just so I can progress to the next part of the demo. And the second part of the demo is to show how Heat can handle this healing. So what I showed in the first part of the demo is just how the network failure affects the host. And it also configured to affect the instance. What I'm now going to show you is what happens when the instance is down, how using Heat, I'm going to configure the self-healing of the instance. So this is a Heat template that is used for the demo. It defines a Nova server, which is obvious, and execute healing is a new type of resource that will be introduced in Train release. It's a Vitrage template that controls the healing process. And it uses a Vitrage template that I will show in a minute. The Vitrage template is a different language than Heat template, does other things. And the Vitrage template determines that a Mistral healing workflow should take place if the instance is down. The Mistral workflow is also defined in the same Heat template. So in one place, you see all the parts connected. This is the Vitrage template. The interesting part is in the bottom. There is a condition that there is an alarm on the instance. It's a specific alarm, not all alarm. And an action to be taken to execute a Mistral workflow. The name of the Mistral workflow is a parameter, and it's given by Heat. So Heat creates the workflow and passes to Vitrage the name of the workflow that should be executed. And now I'm going to create a Heat stack using this Heat template. So this takes a minute. It doesn't look good because I made it very large, but the Heat stack is created. And soon we will see it in Vitrage. So now we have a Heat stack added to the graph. Obviously, it's in OK state because I fixed the problem that I created earlier. And we see in Vitrage templates view, we see a new template that was added by Heat automatically. Now, causing the same failure again, we'll see how it affects it. Exactly what Heat does, not how it affects Heat. So the same alarms as before, and in addition, we have an alarm on the instance that it's down. The instance is marked in error state. This was all done by Vitrage. In the alarm view, we can see another alarm on the instance, and the root cause analysis shows that the instance is also affected. There could be several instances affected, but only the one that is related to the new Heat stack will be automatically healed because we configured it in the Heat stack template. Sorry. I think I just jumped back. We've already seen this. OK. So now, actually, as we were speaking, something happened in the background. So let me just pause it here. So while I was switching menus, actually, as soon as the alarm on the instance was raised, Vitrage identified it and decided to execute the Mistral healing workflow. So on the background, Mistral healing workflow started acting, and it asked, it called the OpenStack stack update to update the state of the Heat stack. And since the host is marked as down, Heat decided to migrate the instance to the other host. So now you can see it's updated. The instance is now connected to the host that is running well. There is no longer an alarm on the instance. The alarm was removed, and the instance stayed is active. So the system was recovered. The system was not completely recovered. We still had the network failure, still one host is down. This has to be fixed, of course. But the specific Heat stack that we deployed, this stack is running well. We fixed the Heat stack. So we did auto-healing for the stack. Now I'll go back to the presentation and explain how exactly it worked. So on the first stage is the Heat stack creation. Heat creates the Heat stack, the server, adds another template to Vitrage, configures it to run the Mistral workflow. A new Mistral workflow that is also added by Heat. Then at runtime, several things happen. First, we have an external monitor, like Zabbix in this case, that reports a problem, that the NIC is down. This is sent to Vitrage. Vitrage uses the topology knowledge in order to understand actually, Vitrage uses its template and the topology knowledge to understand that the instance is actually down, it's unreachable. And if the instance is down, Vitrage asks Mistral to execute the healing workflow that was configured by Heat. Mistral executes the healing workflow, and the heat stack is recovered. I'll explain a bit about the Vitrage template, how it is built. So it holds all the business logic behind the actions in Vitrage. So just holding a graph is nice, but you need to do something based on it. And the template defines the rules, the conditions and actions when you need to do something. For example, you can say, in this example, you can say that if the host is down and the host contains an instance, then there are several actions that you would like to do. You can look at it as a subgraph, for example, a small graph that there is an alarm connected to a host, connected to an instance. And we take this small graph defined by the condition, we run a subgraph matching algorithm to identify all matches in the big graph. For each one, we execute the actions. And in Stein release, we added a new option to write a template with parameters, because we identified that in many times we have very similar templates. For example, if we have a CPU problem on the host, then we have a CPU problem on the instance. If we have a memory problem on the host, we have a memory problem on the instance. The same structure of a template repeats many times. So now it's possible to write a template with parameters like different alarm names, and everything else is just the same, and then you can reuse it quite easily. And now to Heat. In Heat, we are adding a new resource, a Vitrage template resource. This resource will create a Vitrage template and add it to Vitrage. So first thing, you can add any Vitrage template created by Heat. Of course, you would like to use a template with parameters because it's much easier to reuse. You can also send these template parameters that are runtime information that were created by Heat. For example, the name of the Mistral workflow that is created by Heat. And it's very easy to reuse the same Vitrage template for healing, for example, in many Heat stacks. And this is the example that we've seen. I highlighted the important parts. In Heat stack, you define a Vitrage template. You send some parameters like the template name, the workflow name, the alarm name to Vitrage template. And then automatically a complete template is created and added to Vitrage. This template is very, very simple, and it did the work. So you can take exactly this template and reuse it, but you can write very complex templates if this is what you want. For example, here I say if the instance is down, then go and migrate it. But maybe you would like to say, if the instance is down because the network is down, then do the migration. If the instance is down and the network is up, maybe someone just tried to reboot the instance, and you don't need to migrate it. Just wait a few seconds, or 1 minute, or whatever. So you can also write a Vitrage template with complex condition that depends also on the root cause, on other aspects of the topology. It's very flexible. And then if you would like the simple solution that I showed here, 2 steps. You will have currently it's in Gerrit code review, but you will have in the Heat templates repository the example that I showed you. You can just copy paste it, change the names of the alarms, and then you have your own self-healing scenario. It's very simple. You don't need to learn Vitrage. You don't need to learn all the rules and the language. You just need to copy paste and pass the correct parameters. And that's it about Vitrage. So back to you, Rico.
Cool. Thanks, Ifat. So it's a very cool feature that what Vitrage can do and what Mistral can do. And Heat might just adding a color on top of it. And so we have talked about like this kind of self-healing stuff, but is there any place that we can have to people to co-work together? I mean, this scenario would not necessarily to be the only way in OpenStack. There's many, many types of ways. there's a lot of combinations. So we should definitely try to make sure every single working here is covered by the community, and which a community effort will be a self-healing siege, which is happen in the summit as well. Yay! So please join us in the self-healing siege. And the siege is about to trying to cover cross OpenStack project self-healing scenarios and trying to figure out how we can help. And even further, we now plan to have documentations. We already have a lot of use cases. We even trying to have like maybe Tempest scenario tests to actually testing this thing for you. I mean, we're not just talking about it, we action about it, and we want to guarantee that for you for, I hope, forever. Yay. So what's our next step? I mean, so this scenario is, we're definitely going to document it down. So there's a lot of template you've been watching. I mean, you might catch your eyes, but you might not just read through everything here. But I guarantee you that template is not the end of your management. Template is just, you write once, and you can keep using it. I mean, we have a lot of template in the communities, and those template, you can just reuse it, change the names, adding your own flows, and that's done. And you can even have your own fancy way to manage those templates. Just reuse it will be a very easy thing to do. So we're going to document it down and show you how to do it. And like Vitrage have this very cool template resource in Heat. And Vitrage has other workings, and we have other relative working in some very cool like monitoring service as well, like Monaska. And there's a lot of work we're trying to make sure things will be done in the next release, if it's not yet done. But we will try to make sure everything will be in there for you as soon as we can. And if you care about it, you can also come join us to the review. And finally, there's the test. Like what I say, we're trying to have like maybe a scenario test. So we definitely, whatever you're seeing today, we will have a scenario test for this. We guarantee that, which will be upstream and which will be visible for you. That's our way to guarantee things is working for you. Like, we don't want to give you something and say, oh, it might work, but might not. That is our purpose. That's not our purpose. And we might also add on new use case on top of this, right? I mean, so self-healing may be not the only thing you have, but how about you self-healing with other stuff? There's other cool features in OpenStack. You might not actually know every single one of them, but after our work and after in the work in the self-healing siege, we might help you to have a better document, and we might help you to have a better way to see, oh, so here's the thing, and I can combine this, and this is how we config. Voila, and everything's done. Life's easy. Get a coffee. Yep. And so how about, like, let's talk about like one of the scenarios here, like adding an auto scaling. Okay, this sounds like a totally different things here. Self-healing and auto scaling. And isn't there another things working on auto scaling? Yeah, but it's about to actually have everything covered at one scenario. I mean, we say there is a template for your self-healing, and which is cool. And how about we say the exactly same template we can just adding on something, and it can do for to auto scale your self-healing stuff. Like for this example, the yellow circle is whatever if I just talk about that you can do for self-healing, which you will have a monitoring of a Vitrage layer and a Mistral layer to hear what is important for you. And if you write good enough flow to cover your scenario, you can absolutely trust all the root codes and find the right way, the right working flow to actually solve your problems without facing failures here. And so to auto scale, if you see there's the 3 yellow circles, and that means we're trying to scale from the big one and create another 2 new ones. If we run out of the whatever we think is important, maybe, I don't know, maybe memory, right? And you see the button here, everything here is quite simple. And there, you just have to have a monitor to actually check on what's working, what is wrong. Like, I don't know, maybe CPU, maybe network is failing. I mean, like too much like loading for the network. And you trigger that to a queue. You send a message to a queue service, say, hey, so here's the event, and you need to know. I think you might want to scale up or down based on this fact. And so the queue service catch it. And by the way, it can also be Vitrage. It's very cool. So Vitrage definitely do a great job here in the house. You can also do other services like Zakar, which is also cool. And the thing is that after you kill the service, you will have to send a signal back to Heat or back to your orchestrator service. And at the point that Heat will scale out the rest. That entire process look like there's 3 steps, but it actually simple than you can imagine, because to scale out is just you just have to change the resource type as a group, like auto scheduling group, and to put the template you saw into the group. Like, you don't have to write any other things. You just have to have the group and put the template there, so Heat will read the template and create the entire stuff and monitor this and have a scaling webhook for you to actually, you can point it to scale up or down. And also tell him about how you want to scale. You want to batch update it, or how you want to scale, like you want to scale like how many a time, and like for you want to waiting or what, you want to keep going. So everything here is kind of a very good scenario we can have. And so we talked a lot about auto scaling. Let's jump out from the self-healings and be selfish about. I would also like to talk about the auto scaling scene. Yay! So we have other working here together, but it's not 2 forces. It's actually a same group of people, but trying to help with 2 group of users. And so there is the auto scaling siege. We will definitely try to make sure the scenarios is also covered by the auto scaling part. So think how cool it is. So you heard about a use case in the OpenStack, and that use case is covered by self-healing siege and auto scaling siege on the documents, or even further on the templates test. So that means whatever you see, the entire scenario will not break, and we will not say it's not our job, because it is our job, because we are 2 siege here in house. Auto scheduling siege is also trying to cover, there's a lot of auto scheduling, like there's a lot of self-healing. So we're trying to cover other scenarios, but we just knew, which is new in the house. We actually just founded that at this summit. So if you want to join us, please join. And we also have other auto scaling, like there's new cool features in Kubernetes for autoscaler about how you can autoscale, and with Markdown as well. That would be cool. So you can autoscale your Kubernetes on top of your OpenStack cloud. So that's what we have for autoscaling. And last, let's do a summary. So it is quite easy to support your own self-healing scenario. By talking easy, I mean real easy. Yeah, you might need to learn about how to write a template. You might need to know about how to do things right here. But the template is not that different if you start to have a little knowledge here. To use Vitrage to quick identify a fact resource is definitely a cool feature. Like what you saw, I mean, the video just show itself, so I don't even have to add in color on top of it. Like, you can have your own networking detect, your own host detect, and actually find the root cause without trying to guess. Okay, I got 2 arrows in the log, and this is earlier timestamp. Is that the right one? Yeah, but might be other things happening on the other part, and you might not even notice that. But if you have the root cause here, Vitrage actually help you to point to the right one, say, oh no, wait, that is the one. You are wrong. That is the one. That's the root. And so having the root cause identify affected resource will be cool. And auto healing for specific instance among the specific alarms will be like you have heal you can heal based on what you want to learn, right? If you want to change your alarm, do it. It's fine. You want to use external monitoring, do it. It's fine. We do it a lot, and perfect working, and it nicely done. And with interesting bonding on top of auto healing here, all the project you hear today, like Mistral, Vitrage, or Heat, we basically just cover the entire outlook, give you a very synchronized way to see the flow. But beneath it, you actually can do something by your own and adding something around it, like what you say, like what we just told you about. And that will be very cool to have extra things, and you can even contribute back to our communities, which will be you're the most welcome here. And so the solution can be extended to other use cases. Like what I just said, if you have other if you have other service you want to edit, could you edit? Yeah. If you want to heal something more than a node, an instance, it's definitely nearly the same template you're using. You just change how you want to monitor that, and you just change in the flow. Say, maybe this time I want to directly update the entire heat stack, or I want to directly update another cluster to say, yeah, this time something went wrong. Let's change it in this cluster. And with some of the new cool features in the house, you can even like say, yeah, I want to change in this site, in this OpenStack, and say, here, in that cloud, say you want to create something. Everything is definitely possible. If you're really curious about how that can be done, you can find us, and that's what we do. We try to help you. We're trying to help ourselves. We're trying to make this world a better place. And so you can absolutely try to contact us and say, hey, I want to be in the house. I'm the user. I'm the developer. I'm the operator. I guarantee you that we need user and operator and developer. All of them, every opinion matters. And so we have Vitrage, we have Heat. By the way, we also have Mistral. We're not putting here, but Mistral is another cool feature. And so you don't want to miss it. And there is also a self-healing siege and auto-scaling siege we mentioned. So we have something already working on in the self-healing siege and become very active. And we have meetings, we have storyboard to actually allow you to put in like the use case, like the scenario, like the thing you need. And we have auto-scaling siege, which is new in-house, but the meeting is not yet put in the schedule, but we definitely will put it in the very short time. And we welcome people to join the PDG with us and talk about what you like to do in the siege. I mean, siege is for special interesting group. I kind of forgot to mention it, but it's a special interesting group. So it's a special interest. Everybody, if you have a special interest on this group, join us. So let's back to questions if you have.
Very quick question. I think what you guys are trying to do is basically implement the policy and closed loop stuff, which are typically functions of the mono layer. My question is this intended to provide a solution for users that don't have a mono implementation, or kind of like a duplicated mono capability for people that don't have mono, or what is the plan for the special interest group?
So we're definitely not trying to replicate any effort. And if there's any kind of a thing that you think related to the siege, we more than welcome you to put in the siege, because the siege is generally will cover what user. Let's say this way, the definition of the siege is to trying to bridge from the user to developer and also operators. So make sure everything is success and working. So If there is some kind of reactive effort, we are not trying to deprecate or trying to replace anything, but we are very welcome to join any joint effort. So.
Yeah, my name is Doudou Boita. What version of OpenStack is supported? That is the first question. And let's say, what are the requirements to implement this solution for an existing OpenStack cluster?
So it will be supported, it should be supported in Train, so you will not be able to use it in older OpenStack versions. Okay. It involves too much new code.
Okay, what are the requirements, let's say?
If you have Vitrage and you have Heat and you have Mistral, then you can use it. No other requirement.
Okay, last question is, how are you handling the false alarm? You know, some case you can receive an alarm saying that the host is down, and a few minutes later is up. Do you have a kind of validation process before to launch the healing process?
So it depends on the Vitrage template. You can define something like this. I don't have an example, but you can say, for example, that we don't have a time means in the template. I mean, first of all, you can say that your monitor can only report an alarm after 5 minutes, but if your monitor reports immediately, you can say in the template, maybe you are waiting for a combination of 3 alarms, not only one. Maybe you want to be extra sure that the host is down, or maybe if you have all the alarms immediately, you can say in Mistral workflow, wait 2 seconds or wait 2 minutes before you do something. I mean, you have ways to solve it. It's not exactly inside Vitrage.
Okay, thank you.
I think we are running out of time.
Yeah.
So thank you very much, everybody.
Thank you.
Thank you.